In this recording, we're going to learn how to do products of complex numbers that are presented in polar form. And then we're going to convert them into rectangular form. So, for example, I may give you a pair of complex numbers, z and w. Okay, we can see the r and we can see the theta. And how in the world would we multiply such things? So it turns out there's a pretty easy formula that allows us to simply multiply the radii and then add the thetas. Well, where does that come from? And I hate to, as a teacher, just kind of throw that out to a student and say, yeah, accept that. You should just do that, and you have no idea why. It's going to take us a little concentration and a little backing up to sort of prove or present where that comes from, but I think it's worthwhile, because otherwise it's like, okay, I just memorized this formula, but why? So I'm going to try to do a little proof here, some of which is reliant on a previously known pair of identities that I'm not actually going to take the time to prove. I'm actually going to just link in the assignment to Khan Academy, where he has two nice videos if you care to see the proofs of these two sum formulas. But this just says that if I have two angles, A and B, and I want to find the sine of the sum of them, then it's going to be sine of A times the cosine of B plus the sine of B times the cosine of A. Similarly, there is a formula for cosine of a sum of two angles, but it has cosine of A, cosine of B, minus the sine of A, sine of B. So these blue sides of the formula are going to come up in our proof, and I need you to recognize, or I will help you recognize, that in fact those are equal to the left sides. Okay. So say I've got two numbers of this form. You do not need to write this down, but I would like you to stick with me on the proof, and if you choose to write it, please do. Okay. So if I wanted to multiply these, z sub 1 times z sub 2, well, that would require a lot of multiplying out, right? So let's go ahead and multiply out. Well, of course, I would multiply the two radii, but then I would need to multiply out the two binomials. Multiplying the two radii is a piece of cake. Multiplying out these and distributing it all out is going to be a little cumbersome. This is what we're going to have to do here in this proof. So I'm going to basically distributing that. We actually need to create some more space because I see it's going to be a long string here. So let's create some space. Now I'm going to distribute the I sine theta sub 1. Barely fit it in there, but I got it. All right, so check this out. You know a little bit about I squared. All right, so we're going to just say, okay, that's going to produce a negative 1. So this term is going to be a negative. And these two terms are going to both have the I in them. So I'm going to factor out that I, and I'm going to rearrange the terms slightly. So I'm going to take this first term. All right, so we'll take the first term here and the last term, the ones that don't have I. And now I'll take the two terms with I and factor that I out. Okay, I know this looks pretty complicated, but if you're still sticking with me on this, this is what we've got. We've got something here that can be made drastically simplified using an angle identity, as well as here, something that can be made much simpler using an angle identity. So let's check it out. Revert back to our angle sum identities. So we said if we have cosine A cosine B minus sine A sine B, that's equal to the cosine of A plus B. So the two angles, cosine, cosine minus sine, sine. We actually have that right here. Cosine, cosine minus sine, sine. So that's equal to the cosine of the sum of the two angles. And then if I have cosine sine plus sine cosine, okay, cosine of the first, sine of the second, and vice versa, that's equal to the sine of A plus B. And again, guys, If you would like to see these proved, another few minutes of video with Salman Khan. He's a good teacher, and he will show you, a proof of these that derives where these came from. So if that's interesting to you, go ahead and check those out. And what we've got here is I times the sine of the two angles. The sum of the two angles, I should say. All right, so what does this look like? Well, you're going to basically, to come up with your product, you're going to multiply the radii. You're going to add the angles, and that will give us something in the form r cis theta, a radius, and then the cosine of the sum of the angles plus I times the sine of the sum of the angles. So there it is. Let's apply that to the one we were going to try to do initially. We said, okay, you just simply need to, you want to find z times w? No problem. Multiply half times square root of 2. Which of course comes out square root of 2 over 2. And then do the cosine of the sum of the angles. It's kind of showing work here that probably wouldn't be showing on a regular basis here. Plus I times the sine of the sum of the angles. And again, you can make this real streamlined. You could just say, okay, I'm going to multiply those, square root of 2 over 2, times, let's just go cosine of 90 degrees plus I sine 90. And of course, we can just take our abbreviated form here, square root of 2 over 2 cis 90 degrees. So there's our answer. In rectangular form, well, the sine of 90 degrees, if you remember, is just 1, because we're up at the top of the unit circle. It's the y-coordinate up there. And the cosine would be 0 because it's the x-coordinate. So that's a 0. That's a 1. So we really just have 1i times square root of 2 over 2. So the rectangular form would simply be square root of 2 over 2i. I'll write that in a box so it's rectangular. Okay, and I'd like to leave you with this example to try to work out on your own. So pause, make that product, and then play the recording, and I'll work it out for you. Okay, so I simply multiplied the radii, I added the angles. Now I just need to find out what the sine and cosine of 108 degrees are. So the A coordinate would be 14.27. And the B coordinate would be, I can just do it in one step, 15 times the cosine of 108 degrees. Okay. So the A coordinate, I had those backwards. The A coordinate would be negative 4.64 plus BI, which would be the sine of 108 times I. So 15 times the sine of 108, so 14.27. Again, it's 15 times I sine 108. There's our rectangular form of the product. There's our polar form of the product. Thanks for watching.